Part C. Find the time at which the speed of the particle is 3. So let's just remind ourselves what speed is. It's the magnitude of velocity. So if you have the x, actually let me draw it this way. If you have the x dimension of, or the x component of a velocity right over there, so this is the rate of which x is changing with respect to time. And you have the y component of the velocity. You have the y component of the velocity. Let's say it looks something like that. That is dy dt. Then the speed is going to be the magnitude of the sum of those two vectors. So this right over here, the magnitude of this vector right over here is going to be the speed. Well, what's the magnitude of that? Well, the Pythagorean theorem tells us it's going to be the square root of your x component of velocity squared, so dx dt, the rate at which x is changing with respect to time, squared, plus your y component, dy dt squared. This right here is the speed. And we need to figure out at what time is this thing equal to 3. So let's figure that out. So the square root of, what's the x component of our velocity? Well, they told us over here. The x component of our velocity is cosine of t squared. So cosine of t squared, and we're going to square that whole thing, and then plus the y component of the velocity, the rate of change the rate at which y is changing with respect to time. That's e to the 0.5 t, and we're going to square that. So plus e to the 0.5 t, and we're going to square that. This right over here is our expression for speed as a function of time. And we just have to figure out when does this thing equal 9? So there's a couple of ways we could just subtract 9, when does this equal 3? When does this equal 3? And so we could just subtract 3 from both sides and input this into our solver, or we could begin to simplify this a little bit. We could square both sides, and you would get cosine, let me write it this way. You could get cosine of t squared plus e to the 0.5 t, and then squaring that. Well, 2 times 0.5 is just 1. So this is the same thing as e to the t is equal to 9. And now we can subtract 9 from both sides, and we get cosine of t squared. I could have written cosine squared of t squared, but this makes it a little bit clearer, I think. Plus e to the t minus 9 is equal to 0. And now, once again, in this part of the AP exam, we can use our calculators. So let's use our calculators to solve. Let's use it to solve for, in this case, t, but I'll do everything in terms of x. So the equation 0 is equal to, let me just delete all of this actually just to get it out of the way. All right, it's equal to cosine, and I'm going to use x as my variable. Cosine of x squared, close that parentheses, and then I want to square the cosine, the whole thing, plus e to the t, so second e to the, but my variable that I'm going to solve for is x. I'm just replacing all the t's with x just for inputting into the calculator. E to the x minus 9 is equal to 0. We already have this set equal to 0. And so we click enter, and then we could just use our previous answer as our initial guess, and we have to do this little blue solve there. So I click alpha solve, let the calculator munch on it a little bit, and it gets t is equal to, or x is equal to, but this is really t, 2.196. So we get t is approximately 2.196. Did I type that in right? 2.19, yep, and round that up. And we are all done.